You can now watch my videos in Hindi also. Go to the specific video, click on settings, next click on audio tracks, and then change the language settings from English to Hindi. Hello students, welcome back. Let's take up another important question, which is one of the most repeated questions in the board exams. The question is, analyze the following observation table showing variation of image distance v with object distance u in case of a convex lens, and answer the questions that follows without doing any calculations. So here we have been given an observation table which shows the object distance versus the image distance for an object placed at various distances in front of a convex lens. We have to answer the following questions but without doing any calculations. The questions are: determine the focal length of this lens, give reason for your answer, find magnification of the image formed in observation number 3, and the third question is the numerical value of magnification in cases of observation 1 and 2 is same. List two differences in the images formed in these two cases. So in order to be able to solve this question, let's first have a look at the image formation in case of a convex lens for various position of the object. And then we'll answer these questions. Now if we look at this diagram, we see the formation of image at various position of the object. Now before we analyze this, you should remember one thing over here, that the focal length of a convex lens is always positive. Now you see here, when the object is placed at infinity, the image is formed at f2. Now the object distance u is negative over here, whereas the image distance is positive. In the second case, when the object is brought closer to the lens, the image goes on shifting to the right. That is, the object came from infinity to a point closer to the lens, but the image distance shifted to the right. It went further away from the lens. Now in this case also, u is negative and v is positive. The image here is diminished in size and it's real and inverted. Now in the third case, when the object was brought further closer, that is, now the object is at 2f1 or at c1, that is center of curvature 1, we see that the image now shifts further right and is now positioned at 2f2 or c2. Now in this case, the image is real and inverted and is of the same size as that of the object. Now in this case, the object is at 2f1, the image is formed at 2f2. So they are equidistantly placed. So this C1 and this C2 are equidistant from the optical center of this lens. Now on further taking the object closer to the lens, that is, now the object is to the right of 2f1 or C1. Now the image shift further right of 2f2 or C2 and the image is now positioned beyond 2f2. The image is real and inverted and it is magnified. Now in this case, the object distance is negative, the image distance is positive, and so is in this case. The object distance is negative and the image distance is positive. Now let's take the object further closer to the lens and place it at f1. In the next case, we take the object further closer to the lens and place the object at f1. Now the image is formed at infinity. It is real and inverted and is highly magnified. Now in this case, the object distance is negative and the image distance is positive. Now in the last case, we see that when the object is taken further closer and is placed between f1 and the optical center, we see that the rays diverge after diffraction. Now in order to get the image, we have to retrace these rays backwards and see that the image is formed at this point on the same side of the lens as is the object. So here the object distance is negative and so is the image distance. So this case is a special case in which the image distance and object distance both are negative. Now with this idea, let us solve this question. Now for the various position of the object, the image distances are recorded. But when you get this type of question, look at this observation table and see which two values are the same. Now we see that in this case, the fourth observation has the object distance as -40 and the image distance as +40. So in this case, the numerical values of the object distance and the image distance are the same. It means that when the object is placed at a particular distance from the optical center, the image is formed at the same distance from the optical center on the other side. That is, the object distance and image distance are equal. Now if you have a look at the observation table, we see that for this case, that when the object is placed at 2f1 or c1, the object distance and the image distances are the same. So in observation number 4, the object distance and image distance are numerically equal to 40 centimeter. Hence we can write 2f is equal to 40 centimeter, f is equal to 20 centimeter. Since the focal length of a convex lens is positive, so f is equal to plus 20 centimeter, which is the focal length of this convex lens. So we can write this as the focal length of the lens is 20 centimeter, or f is equal to plus 20 cm. Reason: in observation number 4, the object distance and image distances are equal in magnitude. This condition for a convex lens signifies that the object is placed at 2f1 and the image is formed at 2f2. Therefore, 2f is 40 centimeter, which implies f is equal to 20 centimeter. So this is the answer to the first bit. Now come to the second bit. It asks us to find out the magnification of the image formed in observation number 3. So in this observation number 3, we see that the object distance is given by u is equal to minus 30 centimeter. So v is given as plus 60 centimeter. Now we know the formula for magnification is given by m is equal to plus v by u for a lens. V is plus 60 and u is minus 30 centimeter, which is minus 2. Hence the magnification is minus 2, in which the minus sign indicates that the image is real and inverted, and the number 2 indicates that image is magnified and double of object height. This is the answer to the second bit question. In the third bit question, it asks the numerical value of magnification in case of observation 1 and 2 is same. So this is observation 1 and this is observation 2. So let's find out magnification for observation 1. It is v by u. V is minus 60 centimeter and u is minus 15 centimeter. So the magnification is 4. So the magnification of this observation is plus 4. And for the second one, the magnification m2 is v by u, which is plus 100 centimeter by minus 25 centimeter, which gives us a value of minus 4. Hence magnification is minus 4 in this case. Hence the magnification is minus 4 in this case. What are the differences in these two cases? Let's see. First case, we see that magnification value is plus 4, which means that image is 4 times magnified and the image is virtual and erect. The plus sign in the magnification value indicates that the image is virtual and erect. Whereas in the second observation, the magnification is minus 4, which indicates that the image is 4 times magnified. But the minus sign in the magnification indicates that the image is real and inverted. So if you have a negative sign in the magnification, it indicates that the image is a real and inverted image. Now I have made a detailed video on the image formation in case of mirrors and lenses, and also the magnification value in case of mirrors and lenses. I request you all to have a look at those videos because they will help you to clear many of your doubts and help you solve these type of questions very easily. Now coming back to the question, we are asked to find out two differences in the image which is formed. The first difference is that in the first case, the image is a virtual image because magnification is positive, whereas in the second observation, the image is a real image because the magnification here is negative. Now the second difference is that the image in the first observation is upright or it is erect, whereas in the case of second observation, the image is an inverted image because the magnification is negative. Hence, we can write that the two differences in the images formed in observation number 1 and 2 are nature of image. The image formed in observation number 1 is virtual, while the image formed in observation number 2 is real. Orientation of the image formed in observation number 1 is erect, while the image formed in observation number 2 is inverted. So these are the two differences in the magnification value of these two cases. So with that, we come to the end of this video. I hope you have understood the solution to this question. So I request you all to have a look at the other videos in the playlist wherein you will get solved physics questions from the previous year's board exams. So with that, we come to the end of this video. If you found this video helpful, please do like this video, share it with your friends, and if you are new to my channel, please consider subscribing it. Thanks for watching.